Hello, everyone, and welcome to the timely session Building Next-Gen Manufacturing Operations with AI and ML. My name is Ewald Munz from Splunk and Cisco, and I lead manufacturing in EMEA. Before I start, please let me point towards the forward-looking statements because there are quite a few of them in this presentation. Today, I would like to talk about 5 points. First of all, resilience in the manufacturing industry and why it is so closely interlinked to next-gen manufacturing operations. I talk about market outlook, trends, and challenges. Then, of course, most importantly, I focus on AI in manufacturing and how Splunk adds value. With that, I'd like to complement this with 3 real-life use cases with Bosch Rexroth, Zeppelin, and Audi. And then finally, I'd like to conclude with the outlook and share some collaterals. Yeah, to start with, resilience. The manufacturing industry has a long history of resilience. And if you look at this chart, the so-called Global Manufacturing Purchasing Manager Index, you can see that the chart is actually quite fluctuating over time. And of course, the key message is here, resilience is key to recover. For example, when you see at the downturn during the COVID pandemic, to survive when you have, let's say, at the bottom of a crisis, and also to thrive amidst disruption. So resilience is key no matter where you are on this curve. Yeah, and secondly, please let me point out a recent study from the World Economic Forum. They basically describe certain scenarios for competitiveness for manufacturing in 2030. There are certain scenarios, let's say, from a fortress economies with lots of tariffs up to fluid economy with headwinds and tailwinds, and which is, of course, let's say, good for manufacturing or not so good for manufacturing. But the key is here, as before, resilience is key for future competitiveness, regardless of any scenario which might come or might not come. And thirdly, of course, resilience is also key for next generation operations. If you look at the development over time from mass production to mass customization. So let's say in the early 1900s, the start of the Industrial Revolution, where everything was about economies of scale, the mass production to produce the same kind of product as cheap and as efficiently, as cost effective as possible, to nowadays the mass customization. And just to give an example, I mean, from the early beginnings, there was this famous saying from Henry Ford, you can have any color of the Ford T model as long as it is black. Yeah, so not much choice for a customer. Up to nowadays, if you look at the BMW, you can have basically any colors you like, any tires you like, and any interior you like, and any engine you like. So fully customized, powered by the megatrend individualization. And nowadays, it's more about efficiency. So the North Star of a plant manager is the overall equipment effectiveness, a KPI. But of course, this is changing to a very modular, agile, and flexible production up to lot size 1. And of course, this requires a lot of changes and adaptation from manufacturers, and resilience is key. Yeah, what does this mean now for AI in manufacturing? Of course, everybody talks now about AI in manufacturing. It really transforms organizations at an unprecedented rate. And just to underline this with some numbers, there's some estimations that the global market size of AI in manufacturing is estimated to grow 7-fold between 2023 to 2028, reaching 21 billion US dollars by 2028. So a big increase. But what does this AI in manufacturing really mean? Of course, there are lots of definitions. So from my point of view, I can clearly see 5 distinct stages. So obviously, clearly a journey. So starting with, say, with the classics of simulation, of classification, of optimization, utilizing, for example, digital twins for a product, also for a plant, using also augmented reality, virtual reality, obviously also helping with quality control. Yeah. Then, of course, let's say very much the era of machine learning is predictive analytics with the predictive maintenance and the predictive quality. Nowadays, the current hype is, of course, generative AI. For example, very much in customer-facing situations, the chatbots are very much implemented. Also, AI assistants all over nowadays. And of course, let's say in an industrial environment, you can also find now so-called industrial co-pilots. Yeah. The next wave, which is on the horizon, or here already for some companies, is the so-called agentic AI, basically meaning that certain tasks are independently automated and orchestrated. This can be, for example, a response to cyber attacks, or automated optimizations, for example, for energy management, or basically also agentic AI-driven operations in a plant. Yeah. And of course, the last, or not the last, but so far the last step on the horizon is so-called the physical AI, basically combining AI with the robotics. So they're basically AI-driven robotics for production. They're also warehouse robotics driven by AI. And you can also count self-driving cars in the physical AI segment. So 5 distinct steps, but of course, there's more to come, which I will share also in the outlook later. So how do now, let's say, manufacturers embrace this development? And of course, the good news is they do embrace it actually quite a big time. There were some research both from Splunk and also, let's say, from Bitkom, the German IT association. And the outcome is clearly that almost 100% of manufacturers are exploring GenAI in observability. You can see that the number here is 66%. And if you talk about, let's say, specific use cases, anomaly detection is clearly, let's say, a front runner. And looking at the security, they're using GenAI, especially for malware analysis, for threat detection, and for alert enrichment. Now, looking specifically at the German manufacturing industry, of course, also many of them are using AI in production, 42%. And as I mentioned before, physical AI is clearly on the horizon. So currently, 19% are using AI robotics, but clearly many companies, 46%, are planning, discussing to use this more in the future. However, the big shooting star in AI manufacturing is clearly energy management. This is the top emerging AI use case, and 64% of the companies are planning or discussing this to implement this in the near future. So having said all this, how can Splunk add value now? And Splunk adds value, of course, in the context of digital resilience, both for security and observability. And there are 4 distinct steps, starting with the foundational visibility, basically having real-time insights across IT as well as OT environments. Secondly, so-called the guided insights, meaning starting with correlation across different data sources, followed by proactive responses, for example, predictive analytics with predictive maintenance. And of course, the ultimate step are unified workflows with automation. And all this is accelerated by Splunk AI. To complement that, we focus in manufacturing on so-called 4 key business outcomes. Very much, of course, IT, OT security, the backbone of Splunk. Then, of course, next generation operations, which is the topic of this session. Also smart manufacturing, and of course also business process and service monitoring, meaning end-to-end visibility, specifically in the SAP environments. So how does now come Splunk AI in the picture? And to elaborate this, please let me show you a video how this works.
AI has become the backbone of modern IT operations, security, and engineering. Now, enterprises worldwide rely on AI to revolutionize customer experiences, boost productivity, and drive digital resilience. But in today's fast-paced digital world, keeping your operations running smoothly is more complex than ever. How do you detect breaches early, prevent interruptions, and safeguard your business? That's where Splunk AI steps in. Whether it's detecting anomalies in real time, summarizing incidents, or recommending next steps. Splunk AI empowers your team to not only detect, investigate, and respond faster, but is designed to help prevent issues before they happen. Powered by cutting-edge AI technologies like generative AI, agentic AI, machine learning, and deep learning, Splunk AI powers rich analytics and automation infused into our products to help you solve complex IT, security, and engineering challenges. Splunk AI for digital resilience combines unparalleled data from Splunk and Cisco, domain expertise as a leader for security and observability, proven data governance and controls, and AI integrated into your workflow for the best results. With Splunk AI, your team is stronger than ever to deliver digital resilience. Welcome to the future of more reliable and secure operations in the AI era.
Yeah, so Splunk AI is built on a unified data platform of security and observability. And the key word is here, unified, so that you can leverage the same data to give you faster visibility across both security and observability. Now let's click on the AI part. We have built a foundation of AI services and the data platform to transform digital resilience outcomes. And here there are three main components for this: AI assistance, analytics, and automation. AI assistants make your jobs easier across detection, investigation, response, and prevention. Regarding analytics, we've built AI analytics out of the box into our solutions and included agentic AI for task automations. So all of this is powered by leading AI technologies, whether it's machine learning, deep learning, Gen AI, or agentic AI. Gen AI and agentic AI is getting all the hype now, but it's important to utilize the best AI technologies and methods to deliver that AI that's accurate and also efficient. Let's face it, when it comes to AI, efficiency matters. And all of this sits on our powerful data platform, so the AI analytics can readily access all the data to analyze. So let's look now at the Splunk AI assistants first. With the foundation of our AI services and the technologies, we have built 3 AI assistants across our solution portfolio in the platform, observability cloud, and enterprise security. So first, AI assistant for SPL, the Splunk language. It's generally available in Splunk Cloud and in preview for Splunk Enterprise via cloud-connected solution. This assistant has 3 skills: write SPL from natural language, explain SPL, and answer how-to questions. The AI assistant for SPL can be personalized and optimized for your specific environment, helping you to write and edit SPL queries tailored to your ingested data. The AI assistant in Observability Cloud uses agentic AI to complete analysis tasks to detect and troubleshoot faster and recommend the next course of action to take. And lastly, the AI assistant in Enterprise Security can summarize your security findings, investigate those findings in natural language, and generate a findings report summary. So this assistant is now in preview mode. So all these assistants are now integrated into our products and therefore into your everyday workflow. Our vision is to deliver these assistants everywhere in Splunk and with Cisco in the future. Now coming to analytics. So Splunk Analytics and Splunk AI includes a broad portfolio from machine learning, deep learning, to learn patterns, detect anomalies, predicting trends, and rank priorities, for example. It also includes Gen AI that can analyze data and summarize investigation. So all this is pre-built and also customizable. Let me now show you a cool feature of our so-called Splunk Machine Learning Toolkit. This is an app on our Splunk base, basically the app store for Splunk. And the good news is this is of no cost to Splunk customers. So this Splunk Machine Learning Toolkit was recently updated with the version 5.6. And it has this feature of integrating external large language models, for example, OpenAI or Anthropic or Google Gemini. And there's now a new AI command. And now with this AI command, you can connect to these external large language models. This means then that you as a customer have the opportunity to apply the power of these large language models to the Splunk data. And just some examples on the slide here. For example, you can ask, explain the error log that you need to investigate, or prioritize the list of alerts you received, or rank the number of login attempts by user. So very, very nice and useful feature for connecting with the external LLMs. And I will show later in the use case with Zeppelin how they have done it. The analytics now is complemented by agentic AI. And agentic AI may be a new term for some of you. It's a recent AI technology that's become popular late last year, and that we have incorporated as part of our AI innovation. Agentic AI is about a system that can reason and act autonomously. It can process vast amounts of data and adapt to real-time changes in its environment. So how this will work now in Splunk? Agentic AI will help break down a complex task, like something as open as what's wrong with my payment services, for example, and come up with a plan to answer that question. It will then execute that plan to do the analysis and bring back the data for it to synthesize the final response. You determine the goal or the ask, and the agent will determine how to get there autonomously. Agentic AI can remove the human toil from the analyst and deliver faster and more thorough insights. Agentic AI is used in Splunk's AI assistant in observability, and we expect this capability will be added in other products in the future as well. So to sum up, Splunk AI accelerates digital resilience in 3 ways. First of all, boosting productivity and accelerating outcomes with embedded AI, also extending results by customizing AI with your data, and of course also securing and monitoring the fast-changing AI environments. Now let's dive, into some practical case studies, and especially with our customers, Bosch Rexroth, Zeppelin, and Audi, how they have implemented AI in their manufacturing next-generation operations. Let me start with the Bosch Rexroth. They have actually built resilience with the energy management use case for factory automation at their Ulm motor factory in Germany. And this was a Splunk plus Cisco plus a Consist project, which is our partner. And this was a very innovative project. So Bosch actually won for this, the so-called Industry Innovator Award from Cisco as part of the Cisco Global Customer Awards EMEA 2025 program. So really a first for Bosch in this area. And let me explain how this turned out. So first of all, let's say, the background was, of course, the ever-increasing energy costs, especially in Germany. These are skyrocketing. And of course, on the other hand, the increased regulation, for example, the Energy Efficiency Directive, or the CSRD, which requires industrial companies to have an energy management system in place. And of course, to do all this, companies need a unified, granular, and the real-time visibility across IT and OT environments first to, let's say, to put really an efficient energy management system in place. So what have we done from Splunk? So on the one hand side, we leveraged both the Splunk machine learning toolkit and also our so-called Splunk sustainability toolkit. Then secondly, in terms, let's say, of low-hanging fruits, we focused on energy-intensive operations or machines, and then we enabled the optimization with 3 key levers: pricing, specifically peak management, and we will dive into this in a second. Availability, basically optimizing the standby mode of machine, and also timing, basically recommending the best operating windows or operating scheduling for the machines. And basically, as a result of all this, you can see the numbers here. Costs were reduced by 20 to 30%, energy consumption by 10 to 15%, and the carbon footprint was reduced also quite significantly by 25 to 30%. Now, looking specifically at the peak management level, you can see here in the purple color the total energy consumption of the machinery, and in the blue color the energy consumption of the machinery which had the highest energy consumption individually. And the red line on top is the so-called load peak. This is the agreed energy consumption of the company with their utility provider. And this is a very red line, so to say. So every plant manager tries to avoid crossing this or exceeding this load peak, because then the agreed energy price will basically explode to, let's say, 6 times more or 10 times more than agreed. And then this higher price is fixed for the next 6 months or half a year. Yeah? So by all means, the operator, the plant managers want to avoid crossing this load peak. So now with the help of machine learning, with the historical and the real-time data, we could basically see when the energy consumption is coming close to this load peak. And in case of that scenario, we would send out an alert to the operator to reduce the energy consumption, for example, of other machines to avoid crossing this load peak. So very nice use case optimizing peak management with machine learning. And just to repeat the savings with these optimization levels, which were quite significant. So costs, 20 to 30% reduction, energy consumption 10 to 15%, and the greenhouse gas emissions by 25 to 30%. So all this is possible with the help of AI and machine learning. The second case I would like to highlight is from our customer Zeppelin, who actually connected to external large language models. In this case, it was the Anthropic Claude. Yeah, and the reason why they did that was because actually the price information about the used machinery, for example, from Caterpillar machine, was not so transparent. So they connected Splunk to Anthropic Claude. And basically, it allowed employees to query about pricing anytime. Yeah, and just to give an example of such a prompt was, how have Caterpillar prices of this and that machine in Germany changed in the last 6 months? And then you can see basically at your fingertip all this market intelligence coming up. So of course, it enabled employees to make informed decisions, and obviously this was a huge productivity boost for the company. The third case study I would like to highlight is somehow special. So it doesn't, I would say, focus on fancy AI software or fancy AI algorithms. In this case, it shows very clearly that we also have to focus on the foundations when we talk about AI. And in this case, an AI-ready network is really crucial, let's say, to enable all these fancy things which are possible with AI. So in this case, it's about Audi in the plant near Heilbronn in Germany, and that a very pioneering project, basically exchanging the hardware PLCs with virtual PLCs. So basically shifting everything from hardware into applications. So basically bringing IT into the OT environment. And of course, this required a highly critical communication. Basically, the robots had to communicate now to the network in real time. And this was, of course, a first. Yeah. And with the Cisco AI-ready network, all this became possible. And this was really a significant productivity leap for our this strategy for efficient and data-driven manufacturing. And of course, a nice icing on the cake was with this, let's say, virtualization. Also, Audi gained energy efficiency and reduced the carbon footprint. So what is now the outlook, let's say, of AI and machine learning in manufacturing? Well, there's a running joke of plant managers that the factory of the future has only 2 living beings, a dog and a worker. And the job of the worker is to feed the dog, and the job of the dog is to keep any humans away from machines. Will this become reality? Well, just to give an example, we are currently building the next generation factory with our customer Bosch Rexroth, so leveraging both OT, IT, as well as AI. On the one hand side, there's a very innovative product from Bosch Rexroth called Intelligent Factory Floor. So basically, if you look at the factory, only the roof, the walls, and the floor are fixed, and everything else can be, let's say, be flexibly adapted to new production methods or new business models. And this allows, of course, for a very modular, mobile, and flexible production. What I mentioned before, with this kind of next generation vision in mind. So combining this intelligent factory floor with the Splunk platform powered by AI and ML, of course, many outcomes are possible. For example, optimized production performance, availability, security, of course, also safety. Also, lot size 1 would be possible in such kind of model. And of course, also very concretely, energy management, what I mentioned before. So optimizing energy costs, optimizing energy efficiency, and as well as the carbon footprint. But looking more into the future, of course, quantum computing is the new hit on the block, hand in hand with AI. And there are many possible exciting use cases on the horizon, especially with optimization. For example, optimizing complex logistics or supply chain, or scheduling, for example, load scheduling, also workloads in data centers, also accelerating new materials development. And there was the news that, for example, Airbus is active in this space already, and of course, ultimately, also simulations. Let me conclude with a lot of collaterals from AI and quantum manufacturing up to, let's say, explanation about agentic AI, also security use cases with AI. So lots of things to learn and to stay up to date. And with this, I conclude the session and wish you much success with building next generation operations with AI in manufacturing.